Welcome to this lecture number 18, which is on underground cables. But before we do that, we have left something from the last lecture. Performance of long EHV AC systems can be improved by reactive compensation of series or shunt, that is parallel type. This we already talked. Series capacitances and shunt reactors are used to reduce artificially the series reactance and shunt susceptance of the lines, and they act as line compensators. Now, compensation improves system stability, voltage control and transmission efficiency also goes up, facilitating the line energization and reducing temperature and transient over voltages. Compensation reduces Z series line, voltage drops also reduced, power transmission capability increases and constant B goes down, which is equal to Z. Most of the time constant B is equal to Z. Delta V due to series compensation is modified. This expression of delta V is modified here. This is as shown by the arrow, this Xc comes in. So, XL minus Xc is reduced. So, the drop is reduced automatically. There is no change in this term, but there is a change in this term. Select Xc in such a way that this second term becomes 0, less than 0 rather, that is negative, and if you can equate it to the first term, that is beautiful, that is wonderful, you cannot ask for more. What happens? The total deviation is reduced to 0. So, that means you are having a flat voltage in the system, the flat voltage profile, which is a very ideal thing. Of course, it is at a cost, and the cost is you have to equate the two terms, so that it becomes 0. So, compensation factor is defined as Xc by XL, expressed in percentage, then it is called percentage compensation, like your regulation. There is absolute regulation, there is a percentage regulation, you have to multiply it by 100. The extent of effect of compensation depends on the number, what number of capacitors and inductors you are using, location, where are you using, right, and circuit, in what circuitry you are using it, what combination you are using it. Circuit arrangements of series capacitance, shunt reactor stations. So, they, as I told you, if you visit Punky and see that SVS, it is as big as any substation, that big it is. I hope you will go one day to Kanpur and Kanpur to Punky. That is the only station in India on SVS. Optimum connection scheme, people have done master's project, PhD project on compensation to come at a conclusion of an ideal scheme. Number of intermediate stations, of course, cost is always a factor in life, whatever we do, even in US, they do worry, they do bother about the cost, and that is why they have started now outsourcing, and number of people going there are reduced from 2 lakh H1B visa to 65,000, it is about 1/3 now, as they have understood rather than calling the person, it is better to give a job outside. So, this cost minimization continue to remain a very important optimization problem. Series capacitance is very important in India. Why? Any long line transmission needs series compensation, because in India we have, as I told you repeatedly, generation is always confined to eastern part of the country, and most of the loads are in western part. You can see the industrialized states, highly industrialized states are on western side, Karnataka, Maharashtra, Gujarat, and the whole coal belt is eastern belt, that is Bihar UP, MP and Orissa and so on. Now, the series capacitance help in balancing the voltage drop of two parallel lines. Sustained over voltage to the ground, this is a limiting criterion for degree of capacitance compensation, how much compensation you can do. Even resonance, subsynchronous resonance, especially SSR, which is again a PhD topic. Many PhDs have been produced in SSR, is again a very important phenomena which can be produced because of series capacitance. So, series capacitance is a good medicine, but there are side effects, and one of the most important side effects is SSR. A spark gap with a high speed contactor is used to protect the cap under over voltage conditions. So, these are protective devices which you might have learned in your undergraduate. Under light load or no load conditions, I charging is less than I full load rated transmission line current, which is equal to BC into V, total capacitance susceptance, capacitive susceptance rather, and reduction in I charging is because of BC minus BL into V, or you can play with the mathematics BC V 1 minus BL by BC, and this BC V is reduced by this factor. This has to be less than 1 as long as BL and BC both are positive, and BL by BC is called shunt compensation factor. You can read this from anywhere. There is a Wadhwa also gives one full chapter. Our third edition also gives full chapter, or there are papers by Kimbar. You should learn to read from several sources. Right? I don't know whether Pai's book gives compensation, but then Algad I also don't know whether it gives compensation. If it gives, you are welcome to read from any book, because 2 plus 2 will remain 4. Now, if load is withdrawn or gone, then reactors are in to avoid Faraday effect. So, there where you need reactors. Do not think that you do not need reactors, you need only capacitors. So, sometimes load is thrown off by accident. It is a fault, in a way it is a fault. You must have studied in stability chapter in your undergraduate. What happens when suddenly load is off? Because the generation is still there. So, and you take time to reduce generation. It is not a joke, it is not just switching on and off. You have to reduce the steam, amount of steam, the wall has to be closed, or water gate opening, the gate has to be closed. Otherwise, the power will continue to be generated even if it is not required, and that will create acceleration, Pm minus Pe, P input minus P output, Pa, okay, and m d square delta over dt square is equal to Pa. This is a swing equation. So, delta versus t curve, it will start going up for oscillations. So, shunt reactors also play a very important role in compensation. Do not think that they are not required.
Light load.
Yes, no load or light load. Of course, shunt compensation is required for inductive load, and most of the load is inductive in life, in real life. All right. If you have a capacitive load, obviously you use reactors. Shunt capacitance, of course, is more costlier. No, it is costlier, 3 times costlier than series compensation. If it is asked in an interview or anywhere, you can say it is very costly, but it does 3 jobs. So, it somehow compensates. What are the 3 jobs? That gives you example 5.1, the solved one. It improves power factor, it improves transmission line efficiency, it also improves the voltage profile. Series capacitance or compensation hardly has any effect on power factor, whereas shunt, yes, it improves the power factor. And you have seen in that example how from 0.707 to 0.94 or something like that, it gets improved. Compensation is very much needed for larger power transmission, even transmission capability increases, which we need all the time, because at times we have generation, but no transmission facility. As I told you, it is a not a generation problem at times, but it is a transmission problem. Like there is a coal in the coal mines, but there is no wagon to carry it, there is a wagon shortage, the train is not coming, it is going somewhere else. So, there is a problem on power generation in thermal power stations, if they are not pit head stations like Badarpur, like Indraprasth, where coal has to travel all the way from eastern zone to north. Stability is also increased because of compensation. Then naturally, voltage profile is better, the stability will be better. V squared by x, x goes down, V goes up. So, it is a win-win situation, and the transmission line capability improves. Loading capability, thermal, dielectric and stability. These are the 3 important factors. Thermal is ambient temperature, wind conditions. The transmission line will behave in different way in north, different way in central India, and much different way in South India, because the wind conditions vary, the ambient temperature varies. Dielectric is insulation, and stability is of course a very important thing. There are 2 types of stability now, angle stability and voltage stability. And angle stability is of 3 types, that is steady state, dynamic and transient. What are conductor? What are their conditions? Are they solid conductors? Are they hollow conductors? Are they ACSR conductors? Are they bundle conductors? Very few people have shown the diagram in bundle conductor except one. See, the beauty is you must show the diagram, so that the examiner immediately understands without reading that you know bundle conductor. Just to show 2 diagrams, one with a bigger conductor 3 phase and another 2 small subconductors forming 1 phase, 2 small, 2 small. This speaks volumes. If you write pages after pages, it will not have same effect. If you just draw these 2 diagrams, one with single per phase, slightly bigger diameter, another with 2 smaller ones, call it phase A, and then say ds is reduced. If self GMD is reduced, then naturally the x gets reduced. If x gets reduced, it naturally improves the transmission line capability, and so the critical corona voltage will also go up. The corona will occur at a higher voltage. It will not prevent corona, it only prevents the occurrence of corona up to some extent. These are the only 2 lines you write. I do not know what you people are writing unnecessarily. So, you should learn the art of writing, how you will write books, how you will write papers, how you will write your major project report. So, writing is an art. I think they are arranging one workshop on 2nd November, not MATLAB, on how to write a paper, how to write this. You are not aware?
Yes, sir.
So, you should know all these things. There are some 6 speakers they have selected who are going to talk on this. Now, ground clearance is very important. Single circuit, double circuit, multiple circuit, loading capability goes up if you just move from single to double. reliability also goes up, because both the circuits cannot fail simultaneously. The probability is very low, q square. Q is the probability of failure, P is the probability of success. Load compensation, this is different than line compensation. Load compensation is penalty on low power factor loads. There are certain institutions, electricity boards, electric companies, which will penalize you if your power factor is lower than 0.85. So, you are forced to use compensation equipment in your premises, whether you like it or not, because nobody wants to spend money in life. If they can do without spending, they will not, but then there are certain laws which force you to spend money. So, you have to maintain the power factor above 0.85. And how do you maintain that? By installing compensation equipment in your house. How do you save your fridge? How do you save your TV? How do you save your PC? By installing stabilizer. Or how do you want to work when lights are not there? UPS system, big UPS system are also there. Uninterrupted power supply. And see that you operate under balanced conditions. Unbalance is a bigger fault. Unbalancing is no good. Like if you eat just once in a day, whatever you are to eat whole day, that is unbalanced. You are still taking the same amount what you otherwise take in breakfast, lunch, dinner or supper or evening tea. Suppose you add all the 4 and try to consume in the morning itself the same amount, it will be horrible. You are definitely going to fall sick. Though you are consuming the same amount, you are not consuming more, but it is unbalanced operation. This is why we go for balanced operation. Natural loading, steady state limit, thermal limit. So, surge impedance loading, etc., line compensation. Series compensation cannot be 100%. You can't operate line as a resistive line. So, it cannot be more than 80%. This is a rough formula. First of all, it costs money. It is not free, right? And then there is a limit on anything good. Some juice is good. Can you go on taking 50 Mossambi juice? This is even if somebody else is paying. So, any good thing, ati sarvatra bhajeste, no good thing can be taken in excess. So, compensation cannot be more than 80%. Here is a circuit, very simple circuit, where it is shown how a switch, if you open it, capacitor's compensation is in. If you close it, there is no compensation. Or even if you close, go on closing these various switches, different combinations of capacitance in place. So, this is very simple. I mean, you do not need any brain to devise this. Okay. You can have better control, GTO, gate turn off transistors, wider control, solid state control, vector control. There are so many controls nowadays. Smart control, anything, finer tuning. Sky is the limit. I think this slide I have already shown you, that is the facts, margin and all those things, self-regulating to some extent. Right of way is a big problem nowadays. There is no space, and that is why we have to go to our next topic, cables. Why we should have cables? And there is no electricity storage possible. It is very insignificant amount, that battery. So, now we come to next topic, that is cables, which I showed in the beginning of the lecture. Why we go for cables? If there is a possibility, we need not go for cables, because it is costly, right? But because the right of way is not there, because big cities are densely populated. You see Delhi, not a single place is available where you can do some construction. New York, I told you, is one city or metro where there is no space even to stand. So, where is the question of having more and more transmission lines? So, the biggest cable network in the world is in New York, and there where you need this reactors for controlling, because capacitance is too much. And safety regulations also force you not to have a transmission line. There should be 3 feet away from your house. You can't, otherwise children will touch the live wires. So, there are certain safety regulations, how far they should be from railway track, how far they should be from living buildings or any other construction or structure or whatever. All these things you can read in rules, electricity rules. What is the solution? You have just many times we pose problem without giving solution. Solution is insulated conductors, which are underground and they are called cables. Naturally, underground transmission and distribution is very costly. Let me tell you, there are very few books available in the world on cables, exclusively on cables. And one such beautiful book is by V.D. I don't know whether you have read V.D.'s power system book. Now, the latest edition has come with Corey and V.D. So, 4th edition. That book is of course good, but in pure V.D.'s cables book you should read, you should at least. Huh?
That LPE one.
What is LP?
Low priced edition one.
All books are now available in low price thanks to this globalization. Any foreign book is available in 200 rupees. Now, it is no more required you to read Indian books just because foreign books are costly. All foreign books are now available in cheaper edition around 200, 250 rupees, 300 rupees. So, you do not have to read any Indian book just because foreign books are costly. So, this is a real competitive market. If any foreign book is good, you can follow it, you can read it. Cables developed economical, you have to see that they are economic, as it is they are costly, and able to carry large power, because you have to transmit large power. Main constraint is the temperature rise of insulating material used. They are in the underground, right? How do you find out whether temperature, the MATR, what is MATR? Anybody? Maximum allowable temperature rise. This word you should know. When you are done your heating and cooling cycles, those theta maximum, those curves, time constant for heating cycle, time constant for the utilization of electric power in that course, if at all you have done that course.
Yes.
Load balancing, flywheel, illumination, traction. So, there you must have drawn those curves exponential, heating and then cooling. There the heating should not cross maximum allowable temperature rise. But here the problem is, how do you find out whether the temperature rise is crossed the limit, and if so, whether the insulation has failed, because the next impact of the temperature rise will be on insulation. See, anything will attack your weakest part, any disease will attack you if you do not have capacity to fight it. So, the weakest link is always attack. Even in war, the enemy country, you have to attack or enter through the weakest, least protected area. So, the conductor temperature allowed is up to 90 degrees centigrade. Size of conductor is again a limitation. Combination of paper and oil Most effective dielectric for HV cables. Types of cables, mechanical properties required, voltage range, these are various factors. Type of insulation used. Of course, nowadays the material science has made lot of progress. You must have read material science, one subject in your undergraduate. There is one material center also here, polymer center, where you can do any course of your choice if you have time. The insulating material used, good insulation resistance and high dielectric strength, non-hygroscopic. It should not, water should not affect it. Should not react with acids and alkalis. There are acids and alkalis inside the earth, and if you start reacting with them, then there will be problem. They will get deteriorated. Some chemical reaction will start. Fault may develop, short circuiting may be there, and so on. Maximum current rating of a cable is proportional to, or it depends upon, cable size, insulation used, earth thermal resistivity, method of laying cable. This itself is an art. How do you lay a cable? Low voltage applications less than 1 kV, that is a domestic. We use plastic cables. Most of the campuses, good campuses, they use underground cables. You won't see the transmission lines. I think our campus also. Do have you used?
Yes, sir.
Many places. Aluminium is of course getting more and more popular, as you know, for variety of reasons. One thing is it is cheaper, it is lighter, and we produce aluminium more than copper in India.
But aluminum has got a very less current density. That's almost
Not very less, it is less than copper.
2.1 is copper and 1.2 is aluminum.
That's all is enough.
But weight ratio is too much.
The point is, if you do not have copper, what do you do? Say you need coffee, but this shop fellow says I have only tea, and you got up in the morning. You have something hot.
So, but if current density is low, automatically resistance will also be high.
That's all right.
Resistance will be high if you use for long transmission line. It will be comparatively high.
See, overall, it's an optimum. So you have to see three things: availability, economics, cost, and other properties. Naturally, on technical grounds, copper is a better conductor. Who says no?
Gold is
But
not
we gold we don't have. In the minimum gold we had in 91 when Chandrasekhar government came, the whole gold was kept out. The mortgage, we didn't have money. The total foreign reserve was almost rock bottom. Today it is the highest. Forex, the foreign reserve, the dollars. Anyway, that's not the topic here. It's not a management class.
So we compromise on efficiency for cost.
Not compromise. It's not a question of compromise. It's a question of overall optimum. Let me use that word. There is no compromise. Many countries in the world have shifted to aluminium, even those who have copper. So that's why it is not a compromise. Aluminium has proved to be a better conductor overall because the users want aluminium. So even if USA has copper, it cannot use copper because the users don't want copper. Sorry. Yes, there are compensating factors. That's what I'm saying. As he is rightly saying, we can compensate so that that effect is not felt. For example, if your that's what students do. Per page typing in olden days, now everybody types himself or herself. The rates were 8 annas per page, but typists used to take 12 annas. I am talking about those days annas where no paisas. So people used to increase the number of pages so that the money given is same. It is not a cheating or any corruption because you are not earning money out of it. Nowadays what happens, even if you have not got typed, bill is produced for typing. This is corruption. Those days that was adjustment because the government approved rules were 8 annas. The typists used to take 12 annas because the prices have gone up, but the rates have not caught up with it. So, number of pages used to be increased, that is what he is saying. So, you can compensate that drawback of aluminum. Anyway, sheath material also aluminum is used. At lower voltages, oil impregnated paper, insulated cables used with the 3 conductors contained in a single sheath called belted type cable. And here is a picture for 3 core belted type cable. Now, there is a paper insulation is shown here, then there is a jute covering, this is a filler, this is sheath and serving, this is a belt of paper insulation. You can see a better figure in a book, any book. For mechanical protection, we have steel armoring is used. So, we need protection, and jute is final covering. Up to 11 kV paper insulated cables are used. Cable ionization to be avoided. This you must have read in undergraduate, void formation. This question was very popular. How voids are not formed or allowed to be formed, or if they are formed, how do you get rid of that? This question used to be very important. Why there are voids? Due to cyclic heating and cooling. This is the main reason, and there is a cyclic heating and cooling that you know. So, that is why you prefer oil filled cables, because then there will be no voids. So, 500 kV oil filled cable are used, working stress is just 15 kV per millimeter, and gas filled cables are again very popular, especially SF6, nitrogen, air, 3 atmospheric pressure. SF6 circuit breakers are also very important. Similarly, vacuum circuit breakers, we will talk about them also as we go ahead. The final slide for today is good thermal characteristics and high dielectric strength of SF6 preferred for insulating cables. An alternative to the superconducting cable is the resistive operation of an aluminum or copper conductor at cryogenic temperature. Yes, and there is a center of cryogenics in IIT Kharagpur, IIT Bangalore also. Such a cable is called cryo-resistive cable. Well, with this we finish here today's lecture and we will continue on Friday. Any doubts so far?